Welcome to the Real Python Podcast. This is episode 62. How do you know you're using the correct data structure for your Python project? There are so many built into Python and even more that are importable from the collections module. This week on the show, David Amos is back, and he's brought another batch of PyCoders Weekly articles and projects. And we discuss a recent 3-part video course on selecting the ideal data structure, along with comparing the types of dictionaries, data records, arrays, stacks, and more. David covers a recent RealPython article about the namedtuple. This deep dive covers how to use the namedtuple to write cleaner Python code. We also discuss new articles from previous guest Brett Cannon. He's added 2 posts to his Python syntactic sugar series about unraveling the pass and with statement. We cover several other articles and projects from the Python community, including Async and Flask 2.0, Python projects on GitHub that are examples of best practices in good architecture, how SpaceX sort of lands Starship, the new TI-84 calculator with Python, and building a Python spell checker. This episode is brought to you by DigitalOcean's app platform. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, David. Welcome back to the show.
Hey, Chris. Thanks for having me back.
Yeah, excited to cover all these topics this week. We got a bunch of interesting stuff to dive into.
Yeah.
Do you want to start it off?
Sure.
Okay.
Yeah, my first one I brought with me today is an article called Write Pythonic in Clean Code with namedtuple by our good friend Leodanis Pozo Ramos. Total introduction and pretty thorough explanation of what namedtuple is, which is probably, if I had to guess, I don't have any data to back this up, but if I had to guess, it was probably the most used data structure from the collections module.
Yeah.
And so namedtuple is like a normal tuple. It's very similar API. You can, it's a sequence structure. You can put things into it. It's immutable, but you can give each slot in the tuple a name, almost like a class attribute. So it's a really great way to create a class-like experience, but maintain the immutability that you get from a tuple. And he talks about all the different features that it has, how to create them, converting between namedtuple instances and dictionaries and things like that. And then a kind of a little field guide to using namedtuple to write kind of quote unquote more Pythonic code. So, one of the big benefits is that you get these names of these of the slots in the tuple, which makes your code a lot easier to read and understand and adds a lot of context to that. He also talks about how you can use it to return multiple named values from functions. It's kind of a theme here, right? Is, the idea that naming things is always a good idea. So leaning into that feature of being able to name everything. It talks about using nametuples to reduce the number of arguments to functions, and using them to read tabular data from files and databases. So plenty of examples there to look at for ideas of how to use namedtuple in your own code. He also compares nametuples to other data structures and sort of, what are the main differences that they're generally more readable, that nametuples are immutable versus mutable data structures like lists. Talks about memory usage and performance, things like that. And yeah, it's just a great introduction to the namedtuple, which I think, once you've kind of learned the basics of Python and all the kind of built-in data structures that you don't have to import anything to use, then I think namedtuple is really one of the first next steps that you should be aware of and learn to use in Python. So if you're at that spot, if you've never heard of namedtuple before, but you're familiar with all of the other built-in data structures, then this is a great next article for you to check out.
We've touched on it a couple times here on the show. I think we had another article a couple months back, diving into named tuples.
Yeah.
But also, we touched on something that I'm going to go much further into today, which is there's an article by Dan Bader, which was just about all these different forms of data structures, throughout Python. And that's definitely one that's covered pretty heavily there. And so I'll talk about it some more there. But I think they're great. I mean, if you don't have to sort of build the whole class and
Right.
still get the dot notation, you get all this other kind of nice functionality out of it. Named tuples are a really nice reason for importing them from the collections module to work with.
Absolutely.
Yeah, cool. Again, kind of going back in time and talking about a previous episode 47, I had Brett Cannon on the show, and we talked pretty in depth about unraveling Python syntax.
Mm-hmm.
And he's been busy. He's been pretty busy over the last few months with the release of, I guess the beta release, I guess you'd call it, for Python 3.10.
Yeah.
And new versions of Python 3.9 and the Python Language Summit.
Yeah, there's been a lot going on.
We'll talk about a little more. And then this little thing that happened a little bit ago called PyCon. And so Brett's been pretty busy, so he hasn't been blogging a ton, but he just put up 2 more in the series going beyond what I spoke to him about. And this one's really kind of fun. It's just unraveling the pass statement.
Yeah.
So it's maybe one of the shortest ones that's there. And if you're not familiar with pass, if you haven't seen it in code before, it basically is a little block of code that, if you want to define a function and then kind of as a placeholder, you can just simply put indented the word pass as a keyword in there, and it does nothing.
Right.
And which is fine. And it's still, as far as Python, it's still readable and still works fine, but it just doesn't do anything. Or if you're building, out if statements or some other kinds of things, you can use it inside there. And the pass statement, he actually, again, unravels it and goes into the C part of it and disassembles it. And it does nothing. It has like 2 little steps. It returns none, which kind of like the print statement does. And a lot of people don't realize that, but it's just a really kind of a uniquely Python concept. There are other languages where you throw in like an actual like comment type code inside there that's sort of formatted in a certain way to do it. And I was intrigued when I saw it the first time in Python. I'm like, oh, you can just write pass? It's like a game or something like that. I don't want to go this round.
Yeah.
So, which is kind of cool. Yeah. So it's just a null operation. When it's executed, nothing happens.
Yeah.
So.
And one thing that he mentions in the article, although there's not a lot of kind of fanfare around this, and I feel like it's just sort of mentioned in passing, but I think, a lot of people wonder, like, why would something like this even exist, right? Like, why would you even want to do this?
Yeah.
And he says, the reason pass exists is that you can signal that something is purposely empty. And that is the key concept. And I think that, when you talk about, like we were talking about named tuple and readability, this kind of goes into that readability idea that, making clear what your intentions are in the code. And, if you have a case where like nothing is supposed to happen.
Yeah, I actually have one right now.
Yeah.
I'm building this project using CircuitPython, and I was thinking about this problem when I'm pressing a button because it's supposed to spit out a key command. And I'm like, I don't really want it to keep depending on how fast the code runs, even though people think Python is slow, it can still spit out hundreds of repetitions of this letter that I'm having it do on the keyboard. Yeah. And what I've done is just rigged a while statement that basically is this momentary switch. While it's still down, pass. Just don't do anything.
Right. Yeah.
And so it basically, when that key finally is released, or that button is released, then it'll go out. And so that was the easiest kind of thing I could build to kind of do that statement, inside of it. So
yeah, that's a great use case. And I think another case would be when like if you have a conditional, like you're doing an if else or if else statement, and you have a case in that where like nothing is supposed to happen, you could just leave that out.
Right.
right, of your big if statement. But then it's not clear, like, well, was that a mistake? Or like, should it be in there? Did we forget something? So
Right. The
having
sort of
that case,
accident and leaving it out thing.
exactly. So putting it in there is just a way to like say, like, look, it's not an accident. Like, this really is not supposed to do anything. So there are really good reasons that you want something like pass to exist. So
yeah.
But I love, it's the shortest. I didn't count how many words it is, but I mean, it's probably just like a few hundred.
Yeah, it's really short.
Yeah.
Which is cool. Yeah, and then just a few days ago, he released the with statement, which we've talked a little bit about.
Yeah.
Sort of the enclosures of the with statement and how it has, kind of the special code built into it, these dunder methods of enter and exit. And he goes into the details and uses a sort of a CS term that I wasn't familiar with. This resource acquisition is initialization, RAII, and I'll include a link to this Wikipedia article on it.
Mm-hmm.
But to illustrate how it goes, Brett goes into details about using that as a lock example, and basically means that when you create an object, something happens. And by freeing or deleting the object, then something is undone. And so this kind of process of like within this enclosure, like something, you're going in here, you're creating this resource, and then when that resource is done or that code is done, it basically kicks out.
Right.
And the problem with Python is sometimes, the garbage collection and the way things are allocated and stuff is kind of out of your hands. And so having this statement allows the sort of a guaranteed cleanup, kind of built into it, and which is kind of a neat way that this context manager can kind of do that for you. So I won't, go too deep into it, but again, it's fairly short, but it dives into the idea of this, and then he's using it kind of as an example of like locking code for changes. Again, if you're dealing with where you're having something be multi-threaded or some other kind of execution where you need this resource to be, sort of by itself and not get changed outside of something. And so it kind of has this sort of locking mechanic that he's kind of using to explain it.
Yeah, good stuff.
Yeah.
I'm glad he's putting these out again.
Yeah. Yeah. I mean, he's very succinct. And I really like the structure of that whole series.
Yeah.
He also has a recent post that this is about a month ago. There was kind of a big brouhaha about open source and the idea of, what is the responsibility as a maintainer that you have to like this entire vast world of,
right.
Of the users. And he has a really great article. It's called The Social Contract of Open Source. So I'll include a link to that too. So there's like 3 posts here.
Yeah.
But I won't go too in depth into it. But the idea is this idea of like, as an open source maintainer, you're basically giving something away for free. And that should be a big part of the contract socially, And so the way that people sometimes abuse that contract is just kind of gets out of hand and a little toxic. And so I like his explanations that are in there. And we've talked about it a little bit, but this does a good job of distilling his thoughts, at least. So
yeah, that is a good article. Yeah.
So what's up next? What do you got next?
Next one I've got comes from Patrick Kennedy over on the testdriven.io website. And it's called Async in Flask 2.0. So the Palettes project just released new major versions of, I think, like every single one of their projects. And Flask being one of those is now at 2.0, which is a big deal. And it was released on May 11th. And one of the big new features is it adds built-in support for asynchronous routes, error handlers, before and after request functions, and something called teardown callbacks. So it adds all this async. It adds all this async support. And this article kind of walks you through like what the support is and how it works, and kind of Flask's approach to handling async. And one of the things that I found surprising, just because I wasn't following any of this, it probably would have been surprising if I'd been following the development for a while, but it does not use an ASCII server. It still uses a traditional WSGI server, and the WSGI servers are synchronous. So there's, a big difference between how Flask is handling this versus some of the other async frameworks. But you can read about, what all that is and what it means. And it gets into like why ASCII isn't required and everything. But then it dives into, how do you actually do this and how do you set it up? If you've done any async IO programming in Python, it's going to look very, very familiar to you. If you haven't done any async IO programming, then you're probably going to be confused by it, just because async is not an easy thing to wrap your head around first time you take a look at it. Probably even for many times you take a look at it after that. It's a very different style of programming, and the logic is it can get complicated very, very quickly. But it is an important thing to be aware of, and if you need the benefits that async offers, then now Flask can do that for you. It talks about how to test async routes, and the beautiful thing about it is that since Flask handles all of the async processing, basically nothing changes. If you want to use PyTest with Flask, you can go about it using the same way to test all of your async routes as well. It's got lots of examples in it, how to do like asynchronous error handling, all that kind of stuff. It's also got a section on how you can mimic Flask 2.0's async support in any version of the Flask 1.x series.
Okay.
Which is kind of cool. So if you want to kind of test out how it's going to work before you upgrade to 2.0 and go that route, then you can kind of mimic it and get a sense for, how is this going to work with your application. There are, though, some differences there with how you would need to test that. So they give some tips on using the PyTest-async.io plugin to test, async on Flask 1.x. So it's a good article. It's not too terribly long. It gives a really good outline of what the changes are, how it works, and how you can start using it.
What I was going to mention there is if somebody wants a deep dive, there's a really great async series by Łukasz Langa, and we talked a little bit about it. He was actually developing it way back a year ago when we had him on the show to talk about it. But he's working for this new company, and he dives really deep into basically, all the different sort of functions. The company's called EdgeDB. The series, I know it's at least 4 videos, but it goes into it, lots of good examples, and he really does a good job of explaining it. Plus, he's done a few different talks, and we had him to talk about the async IO and music, which was really kind of cool. So, and hope to have him on the show again soon. He did this FM synthesizer thing at PyCon. That was really cool.
Yeah.
It was neat to hear, actual audio processing happening via Python and bringing it into like an actual digital audio workstation. It was pretty slick.
Yeah.
I'm excited to hear about the new stuff in Flask. It's always kind of cool to keep seeing the palette projects kind of improve on them, and all the way up to version 2 now after being in the 0 version forever.
Yeah, absolutely. And there's, I can't remember. I don't know if we've had him on the show or not, but David Lord is one of the principal maintainers of all the palette stuff. And he had this is kind of unrelated, but he had well, it's not totally unrelated. It has to do with the Flask 2.0 update and everything. But he had a Twitter thread on his experience for typing all this stuff. So he's gone and manually added type hints to all of the code in the palettes projects, which I think was a pretty massive undertaking. But that's one of the big things they've done now is it's all fully typed and has all that done. So I'll dig up the link for that so we can put it in the show notes. But it's a cool thread.
Yeah, I'd like to include that. DigitalOcean's App Platform is a new platform as a service solution to build modern cloud-native apps. With App Platform, you can build, deploy, and scale apps and static websites quickly and easily. Simply point to your GitHub repository and let App Platform do all the heavy lifting related to infrastructure. Get started on DigitalOcean's App Platform for free at do.co/realpython. That's do.co/realpython. So my next one is a Reddit thread. We occasionally include these, especially when they get to be kind of a good resource again.
Right.
This goes back to a concept that I've used to have kind of a repeating question early on in the show starting with episode 9, where I had a listener send in an audio recording, which you can still do if you go to realpython.com/podcast. You can still see a link there where you can ask a question. You can send it as an audio recording. And it was about leveling up your Python literacy, finding Python projects to study. And it was with Cecil Phillip from Microsoft, and we talked a little bit about it.
Yeah.
And then again, I mentioned it with another guest, Kyle Stratus, who's been on the show with us and talking about this stuff. The Reddit thread is just full of these GitHub repos and other things that can help. And then I actually found some interesting books in it. So I want to include mention a few things that are kind of cool call-outs. But it's basically Python projects on GitHub that are examples of best practices and good architecture. It's a pretty long title. A really common one that I hear mentioned all the time is requests. And requests is under the PSF now.
Mm-hmm.
So you would see under PSF/requests in GitHub. One that actually Kyle Stratus actually chimed in on the thread, which was kind of cool. And he mentioned one that he had mentioned on the show, which was Anthony Shaw's Wiley. And he actually talked about that in a lot more depth. Kyle had written a article for Real Python that's called, basically sort of best practices on application layouts.
Yeah.
So again, I'll include links to that, and which is a really great article, just kind of like how should you lay out stuff, and again, it's kind of on the theme, right?
Mm-hmm.
And then some that other ones that were mentioned that we talked about, we had that whole thing where I had a project and I talked about ERP Next and their core code called Frappe that kind of was underneath it, which is a great project to study because it just, if you're interested in ERP or you're interested in those kinds of huge projects that can kind of run businesses with all that architecture, it is really well documented. Somebody mentioned Cookie Cutter, which you've probably maybe seen before, getting stuff set up. Mozilla has a project called Kitsune, which is actually fox in Japanese. Black by Wukas Longa again. And then a series of books came up, a series of books that are on a site, aosabook.org. And the book is that's the title there, The Architecture of Open Source Applications. So AOSA. At that site, there's actually 4 different books, not only The Architecture of Open Source Applications, which has a lot of contributors and a couple editors that kind of manage it all together, but there's a volume 2 of that. Another book titled 500 Lines or Less, so kind of examples of code, very clean, kind of tight code there. And then one building on top of that called The Performance of Open Source Applications. So I think all 4 of those books might be of interest, and the languages vary. Which is actually kind of cool. Again, to see structural stuff in other languages is nice. I do see some examples in Python in there, but there are lots of other ones that are like JavaScript or other places. And then finally, I'll link back to another site that's part of the Real Python universe called The Hitchhiker's Guide to Python. If you're not familiar with that site, it's got a lot of great advice. And there's an article on literally called Reading Great Code, and it's lots of good examples there. So great thread, lots more resources kind of continuing that theme. And I'll still try to ask some guests in the future here that question again, if they have other repos that they think would make for good code reading. So
yeah, it's a good thread. There's lots of good advice and good projects on there. I was happy to see that some people mentioned some of the, just built in like Python standard library stuff as well. Cause there's a lot of
Pathlib was one of them.
Yeah. There's a lot of good stuff. I think Pathlib and statistics is another one they mentioned. There's some other good ones, too. But, it's nice to see that because there's a lot of good stuff, even just in Python itself in the standard library. But yeah, it's one of these discussions. I feel like it comes up every few months. There's another thread of like
bubbles up.
But it just goes to show like there's, people need this kind of stuff. It's and one of the best things you can do to level up your programming knowledge is to just read a whole bunch of other people's code because you're going to learn a lot from that. So, and I'll be honest, it's great to know like where all the good stuff is and like what are some examples of like really good, because sometimes you want to read with like, I want to learn the best practices here. I want to see like what is a really well structured application look like or something along those lines. There's a lot you can learn from reading poor code as well.
Sure.
But you get, you have to kind of go into it with the mindset of like, what are the mistakes that are being done here? But But in general, just reading code is, when I was in college, I minored in computer science. So I took a ton of programming classes and computer science classes. And one of the things that I noticed, because I also did tutoring while I was there, I worked in a tutoring lab. And one of the things that I noticed is the folks that were consistently doing really well in their programming classes were the ones that were not just trying to hack out a solution to something to turn in for their project, but were interested in seeing other people's solutions and reading and understanding them. And so that's just, I think, a big part to just being successful in learning any programming language.
Yeah, I could imagine that just sharing your code with fellow students and getting their input
Right.
would be huge. I mean, that's obviously something that would happen in like, a writing course or other things like
exactly.
that, or music. And so those kinds of, it's hard to make yourself vulnerable sometimes to want to share that way, but definitely like just, hey, I don't understand what this is doing. Okay, well, that means I need to increase my documentation or, or whatever. Those are important parts of it. And seeing well-written code, like I was reading through some of them and I looked at the Wiley code, that Anthony Shaw's project. And I really like structurally how he was just laying stuff out. It was really useful for learning a lot about just like things like, how to document your functions and adding those additional notes and stuff like that. It was very consistent the way it was laid out, which is cool. So what do you got next?
The next one is a really fun article I found. It's on Medium, but I don't think it's set up for like a paid deal. So it's freely available and won't count against your Medium number of articles you get each month. It's called How SpaceX Lands Starship, sort of. And this comes from Thomas Godden. The subtitle is How I Accidentally Discovered What I Already Somewhat Knew. Optimization methods are at the heart of landing rockets. So if you're interested in rocketry and, in particular, if you are mesmerized by watching the landings of these rockets, which I think is just a really incredible engineering feat they've managed to pull off and are now doing successfully quite often, at least with the Falcon rockets. Starship is kind of a new one that they've just, I think they just recently had the first successful landing. But this article takes an idea this guy had while watching, while waiting for one of the launches. He decided to pull together some of his knowledge of dynamics and see if he could get a little like 2D simulation to perform what he calls the epic flip, which is when Starship starts as like almost doing like a belly dive kind of, and then it has to do this flip to get itself upright before it lands. So he threw together this little simulation just using like a rectangle to represent Starship and put a little model together and set it off to determine like what the best trajectory was. And, he wasn't like telling it like you need to flip at this time or anything like that. It was basically he put in all the parameters, gravity, all this kind of stuff, and had it start at a certain altitude and know where the ground is and say, okay, find me the best way to land this thing. And when he there's a little YouTube video that he's embedded into the article where he puts his simulation next to like a side view of the actual Starship landing, and it's just mind blowing how spot on his simulation ended up being. It's a beautiful thing to watch that his simulation is just working beautifully. Of course, it's 2-dimensional, so this is not like he didn't somehow discover like exactly what SpaceX is doing here, because it's far less complicated, but still a really neat result. He dives into how it works and what this thing called trajectory optimization is. How do you find the optimal trajectory between 2 points in space, and talks about in like how do you measure what does optimal mean? Is it the shortest distance? Is it there's all these different things that you can consider optimal there. And then what do you do if you've got like the example he gives is like a very simple example is I want to walk from my living room to the refrigerator in my kitchen, and well you're just walking in a straight line is going to get you there quickly and efficiently. But what if there's like a giant pit of death between where you are and
Sure.
and your refrigerator? Well, now like if you just walk in a straight line, you're going to fall into that pit and regret it. So, now we need to go around it. So that ties into the notion of something called a cost function. Talks about, what all these are. I love how approachable his explanations are. And he's got some really awesome, like hand-drawn diagrams that he's got for all of this, which adds kind of a fun element to it. Then he talks about, picking your constraints and what those mean to an optimization problem. Then he dives into, how you actually code this up. And he uses a library that I'd never heard of. It's called CAS ADI or CAS ADI. It's an open source tool for non-linear optimization and algorithmic differentiation. So pretty mathy stuff going on there. But I'd never heard of it. Looks like a really interesting tool. So that's something if you're interested in this kind of stuff, you might want to check that out. But he walks through, setting up the code, how he did it, plotting everything with matplotlib, and then I believe has a link to the GitHub repo where you can see all of his code there. So just a really fun article. And if you're into this kind of stuff, even if you're not into like SpaceX and landing rockets, there's a lot you can learn just on, these optimizations and optimizing trajectories. That has applications, far beyond just space. I mean, there's lots of applications in space with like satellites and things like that. But, self-driving cars and robotics and all that, there's a lot of good stuff to learn there.
Think about all the robots that are being used, for factories or all those kinds of things. Yeah, it makes sense. Makes me, while you were describing that, I was remembering like playing the ancient game Lunar Lander back in the arcade.
I played a lot of that myself.
Exactly. It's like, okay, this could train that pretty easily. So
yes. Yeah.
A lot less dynamics. So cool. All right. Well, this next one is a video course, but it's actually a series of video courses that Christopher Trudeau, previous guest, has created based on an article that was from Dan Bader, but it's really a whole chapter from his book, Python Tricks. And it's all about, selecting the ideal data structure is how he kind of reformatted it. So I worked with Christopher to figure out a way that we could present this massive article as a set of courses. And between him and myself, we've said, okay, well, maybe we divide it into 3 pieces. And so far, the other couple courses had come out. And just recently, the third part has now finally come out. So the entire series is available as video courses on Real Python. And a lot of it's free. You can check it out and see if you're interested and, get a chance to check out some of it. And it dives into the topic that you were mentioning at the top of the show here of when would you want to use a named tuple versus, this structure or that structure. And so the first set of lessons, the first course was on dictionaries and arrays, kind of talking about like, okay, dictionaries, mapping and hash tables. And then he really hones in on why you would want to use maybe the built-in dictionary in a lot of those cases. Something that we've mentioned before, the ordered dictionary, why you might want to go back and use that in that case. Default dict, where you can have stuff built in for that. And we've had other articles and other kind of deep dives on this. What's nice is it like, even though we have all these real deep dives on a lot of these structures, this kind of is like this really nice survey across all of them. And then it adds the little bit of extra advice like, okay, well, commonly you would probably use this, and this is why, at the end of each one of these sections. So, a whole thing on dictionaries, even chain map and mapping proxy type, and then an area on arrays. And if you're not familiar with that in Python, an array would be a list or a tuple in most cases. And then there are things like typed arrays and strings, and then even getting into binary arrays. So then the second part, the second course that was divided into it was talking about having records, things that you could kind of think of like sort of database structural sort of things that might be a class, or we mentioned it before, a named tuple, why you may want to just simply use a dictionary versus, a tuple or a class or a named tuple. And then also mentioned structs. And then again, what would be an ideal data structure for the project that you're working on? And then it goes into sets and frozen sets and multi-sets, this thing called the counter, which is a really kind of interesting class. The most recent one that just came out is about stacks and queues. And if you're not familiar with a stack, that sort of structural thing is where you have sort of what's called last in, first out, sort of like a stack of plates. As you add an additional plate on top of the stack, you're most likely going to take the top plate off of that and not go for the bottom plate. And so that kind of LIFO, last in, first out structure, and how lists are typically used for that. But in some cases, depending on what you're wanting to do, there is another one called a deque, which is spelled DEQUE, and also something called a LIFO queue, which can be imported in. And again, why would you want to use one or the other? And then he goes into queues, and queues are much more of the idea, sort of first in, first out, kind of like queuing up for a line to go on a ride or something like that.
Yeah.
Hopefully, structurally, that's how it should run. No one cutting in line. And it talks about using a list for that, or again maybe a deque, and then actual the queue, and then kind of goes into, this is where it sort of dives into this deep idea of parallelism, and again, where you may want certain structures depending on how you're set up your code. And he goes into some kind of nice deep examples of where if you're doing parallel type of computing, you may want to pick one over another. And then it ends up on something called the priority queue and the heap queue inside of there. So again, it's very detailed. We had mentioned it way back in episode 27, the article coming out when we had Jim Anderson on. We talked about the common Python data structures. And then this is just sort of a restructuring of that with a lot of additional advice and really great deep dive into all those areas. And it made sense to cut it up. Otherwise, it would have been a huge single course.
Yeah.
So check it out.
Yeah, it's good stuff. And it just is one of the beauties of the Python standard library that you get whenever you install Python, is that you get all this stuff out of it. And I think most people are familiar with the built-in data structures like lists and tuples and strings and dictionaries and sets and that kind of stuff. But there's so many other data structures out there.
Yeah, varieties.
And Python has a very wide selection of them that are ready to go. You don't have to implement any of this stuff yourself. And a lot of them are implemented extremely well and are, very efficient and
optimized.
And so they're really good choices for that. They're not the only choices. I mean, you have lots of other libraries that you can pick from, but yeah. And so, once you've kind of reached that level where you're ready to sort of dive into this stuff, then it's great to have these resources, because there's a lot that just plain old Python has available to you.
Yeah. Not needing to roll your own version of a lot of these things, though we do have examples. Sometimes if you wanted to, if you're wanting to learn more about, algorithms and different ways of implementing the stuff on your own. But yeah, it's neat to kind of see it all and kind of get an idea so that you can go in to a programming situation, and really have a good idea of okay, for my specific use case, this is probably the best idea.
Right.
So,
yeah.
This week, I want to shine a spotlight on another Real Python video course. It's the one that I was mentioning earlier in the show. When you're starting a project, one of the big decisions you need to make is how you're going to store and work with data. And Python provides a variety of built-in tools. In previous episodes, we already featured the first part of the 3-part series, which was about dictionaries and arrays. This time, we're featuring the recently released third part. It's titled Stacks and Queues, Selecting the Ideal Data Structure. And now, all 3 of the courses are ready for you to check out on Real Python. And they're all based on a Real Python article by Dan Bader. In the course, previous guest Christopher Trudeau takes you further into the wide variety of built-in mechanisms Python has to meet your data structure needs. In this course, you'll learn about how stacks are defined with last in and first out semantics, how to use the collection's deque object, which stands for double-ended queue, how concurrency will affect your choice, what are priority queues, which data structure methods are thread safe, and how to decide between all of the implementations of these data structures. I think it's a worthy investment of your time to learn the variety of ways of storing and managing your data in Python programs. The choice of the right data structure will affect not only the readability of your code, but also the ease of writing and performance. And again, as a reminder, there are two other parts of the series. The first is about dictionaries and arrays, and the second is about data records and sets. Each one dives into the variety of choices and advantages those different types have over one or another. Our video courses are broken into easily consumable sections, and where needed, we include code examples for the techniques shown. And all the courses have a transcript including closed captions. Check out these video courses. You can find a link in the show notes, or you can find them using the newly enhanced search tool on realpython.com. All right, we're diving into projects. What do you got?
Yeah, so I guess it is a project. It's not an open source project, but it is someone's project. But before I get to it, I wanted to start with just a quick mention of another Reddit thread that I found that it says, do you also use the Python console and the Python math libraries as a calculator? And it's a kind of a thread of people just talking about how, if they need to do some quick calculations and they're on their computer, they can quickly open a terminal, start Python, and then just immediately start, doing that and not have to, use a calculator app or pull out their phone or, have a desktop calculator or something like along those lines. And it's got some good tips and tricks in it on how you can do that. But the reason I bring it up is that the project is kind of the complete opposite of this. This is from Texas Instruments. It's a new TI-84 calculator, which I think anyone who has gone to high school in the US in the last, 15 to 20 years or so has probably used a TI-83 or an 84 and knows these things. Well, now there's a new one. It's a TI-84 plus CE Python. And the calculator has Python built into it. So I remember, I can't remember exactly. I think it was some like variant of like BASIC or something that they had on these calculators.
Yeah.
It's been so long since I've used one, but you could do some like little scripting and some little things like that. But the programming language was not super user friendly. And I think, there were a few nerds that were like myself in class that would get into it and try to, mess around with it. But for the most part, people never messed with that part of the calculator. So now on this new one, which is I don't think is available yet, and I don't see on the website like when it's going to be available, other than I think saying it says fall 2021. But now it comes with Python built in, so you can actually code in Python on the calculator, which is interesting. I'm not sure how great of an experience. Like my big question is like, how am I going to enter the code? Like how
typing in, there's no autocomplete. It's not like an IDE or anything.
Right. Yeah. But it's still a really cool, development. This is, if this is something that students start using, I mean, this puts Python in the hands of students all over, potentially all over the US and other countries if they decide to adopt these calculators. So yeah, I just thought it was funny. I was already reading this Reddit thread. Do you use Python as a calculator? Well, now you can use Python on your calculator. So, yeah.
Nice. Yeah. I'm excited by seeing more and more places Python being used, more and more devices accepting it, going into like the project I mentioned earlier, the Circuit Python, and I keep seeing all these different versions of Raspberry Pis in different sizes and so forth. And so it's neat to see Python kind of expand out in all these different areas and widen it up. And yeah, it's cool.
So it does have a little editor built into it.
Okay.
With menu selections, color coding assists.
You save your little code scripts and okay.
It's got a shell built into it. So it's got the Python shell. It has a little file manager they've added to it. They've got their own plotting library called Plotlib to visualize stuff with it. And so it's interesting. I just wonder, like, can you like connect like a Bluetooth keyboard to this thing? I don't know. I'm trying to see if there's anything here to make it easier to actually enter.
Fully wannabe QWERTY kind of thing, or
right?
Yeah. Okay.
I don't know.
Well, my next one is one that you found that's about spelling and spell checks.
Yeah.
And it's by Victor Shepolovev, and he has a blog. He's actually a by trade sort of a Ruby programmer, and he goes by the name I don't know if I could pronounce it, but Zverok, Zverok, and a Zverok with Ruby is his blog. And so he went down this massive rabbit hole over the last year and a half or so, and he started working on porting this thing called Hun spell, Hun spell, which is a kind of popular spell checker that's out there in kind of the open source, and it's up there on GitHub. He wanted to make it work in Python, not only to learn Python, but also to learn about spell checkers. And it's funny, the blog, I won't spoil it for anybody, but it's a really kind of a fun journey. I'll include the link to it, but it's just basically, I'll include the top line of it. I spent a year building a spell checker, and all I got is some grumbling to share.
Yeah.
And it's kind of fun to follow through and kind of think about like, okay, well, what you may think as a simple domain problem and all the different variables that go into something, when you really get inside of it and start to put it to use, it just goes exponentially, just like language itself,
Yeah.
And the things that can happen. And so another little area I'll share is just some of the things that you may not think about when you're trying to deal with, spelling something is just things have changed in style. His example of Google becoming a verb,
right.
In not only, present tense, but past tense Googled,
right.
and things like that. It's kind of crazy. And then just the idea of like words change their meaning when they're surrounded with other words. And the topic of the text, is it technical? Is it in a certain domain? I deal with it all the time with European spellings. Got a lot of Europeans and Canadian people working for me, and I have to catch their spelling sometimes with bonus E's and U's in there and stuff.
Yeah.
It's like, okay. It's neat. It's a neat project, and the project's called Spylls. I don't know if I even mentioned it. So SPYLLS, and actually is something that you can just pip install. He has put it up on PyPI, and it's a neat project to check out if you're interested in kind of learning a little more about how a spell checker could work. And again, it implements the Hun spell, which is again a popular spell checker that's out there. And so you could again import it and use it in something that you're creating if you need additional spell checking. You're thinking of making a text editor or what have you, which is a common little project that some people like to add. This would be a neat feature you could add in with this extra library.
Yeah.
But yeah, check it out. So Spylls, spelled with a Y instead of an E.
Yeah.
All right. Well, I think that covers it for this week of PyCoder's stuff.
Yeah. We talked about a lot of stuff today.
Yeah, I know we covered a lot of different areas. We
Yeah.
have so many bonus additional articles and areas for people to check out. So
Good stuff.
great. Well, I'll talk to you soon.
Yep. Thanks, Chris. See you later.
All right. Bye. And don't forget, you can get started on DigitalOcean's app platform for free at do.co/realpython. That's do.co/realpython. I want to thank David Amos for joining me again this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.